In this session, we'll take up the detailing of reinforced concrete beams. The first beam, what we'll deal with the simply supported beam. So in this detailing, the special publication by Bureau of Indian Standards SP34 will help us to provide the details of reinforcement in reinforced concrete structures. So we'll be referring with this code here. So here is the problem on a simply supported beam. You need to prepare the details of a reinforcement for a beam supported on a masonry wall with a clear span of 5 meters. Details of reinforcement are at the midspan, 4 bars of 20 mm diameter are provided. Shear reinforcement are in the form of two-legged vertical stirrups whose diameter is 8 mm and are spaced at 175 mm center to center. The size of the beam is 375 by 230. In depth, it is 375 mm and width of the beam is 230 mm. And properties of material, concrete is of M20 grade and steel is of Fe415 grade. So here is what we have, the details of the reinforcement in case of a simply supported beam. So this is our beam and supports. What we have is a brick masonry wall and main reinforcement is at the bottom, and the top reinforcement here will be at least two, which will be the hanger bars. So in any case, even if the beam is not provided with any reinforcement in compression, as we do in case of doubly reinforced section, uh, every beam has to be provided with two bars, which will serve as a hanger bar to hold the stirrups in position, in a proper position. So these top bars will be minimum two in numbers whenever you don't have a compression reinforcement given by the design. So that is this top reinforcement. Now coming to the main reinforcement, which is there at the bottom on the tension side of the beam. So this 100% is required in the mid span of the beam. Okay. As you move towards the support, in case of a simply supported beam, the bending moment will reduce. Theoretically, it becomes zero at the supports. So you no longer require this 100% reinforcement towards the support. So in order to save the steel, we can curtail these bars. So the curtailment point has been shown in this particular figure here. So what is given here is 0.08 times the L. Okay, 0.08 times the center to center distance between the supports. That is the span what is referred over here. That is 0.08 into the center to center distance between the support. That at within this distance I can go for curtailing the mean steel in this beam. So I can stop the reinforcement. What quantity of reinforcement can be curtailed? So you can see here 50% can be curtailed. So at least 50% should be available up to the support, and that should extend within the support to a distance equal to LD by 3. So 0.08 times the center to center distance between the support. This is the region in which we can curtail the bars, and we cannot curtail more than 50%. At least 50% should continue up to the support and within the support. Okay. Now coming to the LD here. So this reinforcement, what you have, it has to extend into the support to a distance of LD by 3. So what is this LD? This is the development length what is required for bars to develop the design stresses effectively. So this LD we can obtain or we can get it from IS 456. So in this 26.2.1, in this particular clause in page 42 of IS 456, you'll come across the development length given here. So we have the expression what is given here, LD equal to 5 into sigma s upon 4 times tau Vd. Here phi is the nominal diameter of the bar which are there, which are provided as a main reinforcement, and sigma s is the stress in the bar at the section considered at the design load, and tau Bd is the bond stress. So sigma s in case of working stress method, we have it as 0.87 F5. That will be the design stress, factored stress in the reinforcing steel that is considered. And the bond stress depends on the grade of concrete. So in the next page in this table given here, that is in 26.2.1.1, you can get the design bond stress for any grade of concrete. So for M20, it is 1.2. For M25 grade of concrete, the bond stress, design bond stress is 1.4 Newton per mm square. Like that, we'll get it for other higher grades also. And one more thing, what is mentioned here is for deformed bars, you can increase this bond stress by 60%. That is, the bars with the ribs, for such a bars, we can increase this by 60%. Whatever the value is given here, that can be increased by 60%. And when a bar is in compression, the further this value can be increased by another 25%. Okay, if at all the bars when they are in compression, you can increase this bond stress by 25% in addition. So 60% for deformed bars and another 25% if at all the bars are in compression. So that will be the development length how you are going to obtain. So in our case, what we have for our problem, what is given here. So we'll look at this problem. The span is 5 meter, okay, and size of beam is told to us. Width of support, we'll take it equal to the width of the beam, that is 230 mm. Okay, so center to center distance between the support comes out to be 5 meter plus 0.23 by 2 plus 0.23 by 2, half the width of the support on either sides. So totally the center to center distance between beam comes out to be 5.23 meters. So this is what I can write here. The data what we are having. If I take this problem, first is the given data. Clear span is 5 meters. Center to center center to center distance between the supports, it will come out to be 0.23, half the width of the support on left side, plus the clear span, plus half the width of the support on the right side. So this is the L value what we have, 5.23 meters. So that is 5.23 meters. And also what is there? The main reinforcement, that is a reinforcement at the bottom. So main reinforcement, we have it as 20 mm diameter bars and 4 numbers. Okay, then shear reinforcement, they are two-legged stirrups, two-legged vertical stirrups. So I have two-legged vertical stirrups of 8 mm diameter and spaced at 175 mm center to center. Okay, so this is the shear reinforcement. These are the details of the reinforcement what I have. Now, in addition to this, for preparing the drawing, which shows the details of reinforcement, size of the beam is given. So in this case, width of the beam is 230 mm and the overall depth is 375 mm. Okay, width of the support, we have taken it equal to the width of the beam, even if it is not given. Next, what we require is we'll take the clear cover to the to the reinforcement, any reinforcement. So clear cover to the reinforcement, we'll take it to be 25 mm. Okay, so in case of beams, we'll adopt it as 25 mm. It depends on the type of exposure and also the maximum size of the nominal aggregate. So let us assume that to be 25 mm in this case. And now we need to obtain the development length for our case. So here I'll go for calculating development length in tension. Okay, so what I have, the equation is LD is equal to diameter of the bar pi into sigma s divided by 4 times 2BD. This I have taken from IS 456. You'll find it in IS 456 2000. That is in page 42. Okay, so that is the equation what I take. And here in this equation, phi is the diameter of the bar. I'll not substitute for any diameter of the bar. We'll tell it in terms of bar diameter. Okay, and the value what I require next is sigma s. So it is 0.87 times Fy. Okay, in our case, grade of steel Fy is Fe415. That is yield stress is 415 Newton per mm square. This was given to us. Okay, so all right, so sigma s is 0.87 Fy, which is the design stress in the steel, and tau BD. Okay, tau BD I'll take it from the IS 456 table itself. So here tau BD, what I have for M20 grade of concrete, okay, it is 1.2 Newton per mm square. And since in our case the bars are deformed bars, I can increase this by 60%. So what I have here is this will be 1.6 times. It is increased by 60%. 1.2 is the actual value, 1.2 Newton per mm square. So this, if you increase it by 60%, it will be 1.92 Newton per mm square. So this comes out as 1.92 Newton per mm square over here. Now, if I substitute these in the equation LD, I'll be able to get what will be the development length. So this comes out as this bar diameter, we'll keep it as it is. So this is 0.87 into 415, that is sigma s, divided by 4 into 1.92, that is 2BD. So what we have, that is the 0.87 into 415 divided by 4 into 1.92. So this gives us 47 times the diameter of the bar. So LD is 47 times the bar dia. So this is the development length for any bar which is in tension. If you want to know what is the development length for bars in compression, this can be further increased by 25%. But at present, this is enough for us. So this will be the provided information provided in the drawing, and at the side they should execute this LD should be provided. Like in this case, the bars have to extend to a distance of LD by 3 into the support. Okay, so that can be achieved by knowing what will be the LD in terms of bar diameter. Now coming to our actual detailing part. So we'll begin with the detailing over here. So before we go to the AutoCAD and start drafting it over there, let us put a sketch for this one. In our case, for our beam, how it would be. So first is this longitudinal section. So this is the beam. Okay, so this is what I have, and supports, they are the masonry wall. So the supports at the two ends, these are masonry walls of thickness or a width 230 mm. So this is the masonry wall. Okay, so then after this, what I have is, so these are hatched. This is also the masonry wall on the other side, and from here to here, this will be the clear span. That is from face of one wall to the face of other wall. That will be our clear span. So this clear span, what we have is 5 meters. So this is 5 meter. Okay, and width of this wall. So this is 230 mm. So on both sides, the width of the wall. This will be the sketch what you need to prepare before you work into the AutoCAD. And then the beam, what we have within this beam is the reinforcement. So this is the bottom reinforcement, what I have with the clear cover over here. And the top reinforcement. So this is our top reinforcement. Top reinforcement in the sense we have hanger bars, because nothing has been told about the compression reinforcement at the top. So now top reinforcement will serve the purpose of hanger bars. Actually, they are required for holding stirrups in vertical position. So that is the top reinforcement, and from here the shear reinforcement will start. So these are our shear reinforcement. Okay, so this shear reinforcement will be spaced at 175 mm center to center. They are two-legged vertical stirrups spaced at 175 mm center to center, like this. So from one support till the next support, this will continue. Okay, so this is the shear reinforcement what I'm showing now. As a beginning part, first is you need to prepare this writer, that is the details of reinforcement, you need to show it. Then you can go for executing the same with the AutoCAD. So these are the shear reinforcement. Okay, And now one more thing what I need here is the curtailment. Where is the curtailment? Where we are going to do the curtailment. So curtailment length or the region in which bars can be curtailed has to be calculated here. So what I have, curtailment point. So this is 0.08 times L from face of support. So this comes as 0.08 into 5230. Okay, 5.23 meter is the center to center distance over here. So in terms of mm, that comes out to be 5230. So it will be 418. Okay, so this is 418 mm from the base of the support. Anywhere within this distance, we can go for curtailing the bars over here. So I'll show that point over here. So this is the point where you can, or this is the length within which you can go for curtailing the bars. Okay, and you cannot curtail before this distance on either sides. Okay, towards when you come towards both the supports, these are the curtailment points over here, which are 418, or you can round it off suitably. It is coming out to be 418, so I'll show it as 400 mm. Okay, so well within this distance I am going for curtailing. It is better you always follow units in mm when you are working with AutoCAD. Okay, here some units are given in meter, but in AutoCAD we'll be following only the mm. Okay, so this is the point. So beyond this, the bars have been curtailed. It is shown by such a kink in the bar like this. It indicates that curtailment has been done over here. Now the next thing what is there is about detailing these reinforcement. So first is here at the mid span, what I have 20 mm diameter bars which are 4 in number. Okay, and on the top what I have is these are hanger bars. So 10 dia, if not given, these normally it will be specified what are the hanger bars. They are 10 in 10 in diameter and 2 in numbers. So these are the top hanger bars. Now once I come towards this support, so here what is done, here the curtailment is done. So I can curtail at the max 2 bars. So what are available here, 20 dia. Okay, 2 numbers are available. Okay, so that is what we can do. You cannot curtail more than 50%. So 4 bars half have been curtailed 50%. These are what, 2-legged 8 mm dia at 175 mm center to center. These are the shear reinforcement. Okay, and after this you need to provide the details of the section, details in the cross section. So two cross section we'll choose here. One is at the midspan, one is near the support. These are the cross section what are required to represent the details of reinforcement. Because curtailment is done here, so bars will change. The bars are going to change. That's why I'm taking two sections, one at midspan, one at the support here. Okay, so what happens here in cross section? This is the cross section at the midspan, that is at section 1 1. So this will be our section 1 1 section before curtailment or at the midspan. This is section 1 1, and after curtailment I'll take one more cross section over here. This is section 2 2. Okay, so we'll show the details of reinforcement at these two cross sections. So here is what I have. This will be the stirrup within this. This sketch has to be prepared manually by you. Okay, so the stirrup. So same will be the stirrup over here. These are the shear reinforcement. This is how they will appear in the cross section. And here somewhere you'll find these hooks which will be coming. Okay, so at section 1-1, this is our section 1-1. The width is 230 and depth is 375. For this also it is 230 and 375 depth. Okay, so now about the bars. What I have, bottom there are 4 bars, 1, 2, 3 and 4. These are the bottom bars at the section 1-1. On top side what you have is 2 hanger bars. That's all at the 2 corners. Here 2 hanger bars at the 2 corners will be there, but on the bottom side the 2 reinforcement which are in the middle, they have been curtailed. So these are the section, cross section at midspan and near the support. So this is my section 2-2. This is 2-2 cross section. Okay, so this is how you have the cross section over here. So once you do this, here also detailing is required. You need to provide as much as details as possible in the drawings. So drawings will be referred in your site. We don't give any design calculation in the site, in the construction site. So drawings are very important from that point of view. So here, what are the details you need to prepare is, for this, what I have, bottom reinforcement, 20 dia, okay, and 4 numbers, top reinforcement, 10 dia, and 2 numbers, okay, and these are the stirrups. This will put it other side. So 2 light vertical stirrups, 8 dia at 175. C bar C, center to center, this one. Okay, so let us say this is 375. Okay, so these are the size of the beam. Here what you have, 10 dia, 2 numbers. Okay, so diameter of the bar, simple, 2 numbers. Sometimes they just put it as a white 10 also, that also refers as 10 dia, 2 numbers. So here it is 20 dia and 2 numbers, and these are again 2 legged 8 dia at 175 center to center. Okay, so these are the cross-sectional details what you have. So this has to be prepared in our AutoCAD. So we'll go with this AutoCAD here. Metric units, so we'll be using that one. And remember, all the drawings are in all the dimensions what we are preparing are in mm. Right. So starting with the launcher section. For the launcher section, I require a rectangle here. So what I have, the first corner I'll take it to be 0, 0 at the origin, 0, 0. The next corner, what is there? X will be 5000 plus 2 into 230. Okay, so that will be 5000 into 230, 5460. The overall length of the beam is 5460, and height will be its depth 375 mm. Okay, so this is my launcher section of the beam. Okay, now at this, what we will do is we'll also show the supports which are there. So here, this is the support here. So what I have, 230 as the width, and say some 300 mm depth, just to represent that wall. I'll take that depth. Okay, so this is the left support, and also we have this as the right support. Okay, here. So this becomes my launching section of the beam. I'll place it somewhere here so that it will be visible. Right. So now what I require is I need to hatch this. Okay. So hatch these supports. Okay. So to represent the wall, this is what we will be choosing here. Pick points within this and also within this. This is scale as 50 plus 25. Yes, this is fine. So this will be our wall. Okay. Now what I have is I need to show the reinforcement. I'll simply offset this rectangle inside. Okay, so offset command, you can choose it. You can get from the quick access menu, or you can just type O. Okay, command O. It will give you offset, and it is asking to specify offset distance. So clear cover will be my offset distance 25, 25, and I want this object to be offsetted within this. Okay, fine. So here it is a rectangle. Now let's just explode this one. So I'll get line segments here. So now we have the line segments. So my reinforcement is ready now. Okay, both reinforcement are appearing here. Okay, I just have to arrange them now. So what we prefer is normally the reinforcement line weightage will be more as compared to other edges of the concrete. So for this, I'll increase the line weightage slightly. I'll make it to be 0.25. Let us keep it 0.25 other than this one compared to the other edges or lines. Okay, so line weightage. Now you can see it is appearing thicker than the other lines. So you can adjust them accordingly. Don't go for keeping too much of line weightage. It will not appear properly in the print. 0.25 should be okay. Now I have top reinforcement and bottom reinforcement. Also, there is one line which is showing the stirrup. Okay. Now we'll increase these numbers. So I have one row and column, since they are spaced at 175 mm center to center, and overall length of the beam is 5460. Okay, so 5460 divided by 175, it comes out as 31.2. Let me give it as 32 columns here. Okay, so row offset and column offset. Right, column offset is 175. Number of rows 1 and columns 32. Okay, so row offset we don't require that. There is no second row coming here. So what I have now, this is my shear reinforcement. Okay, so this you just move it inside the beam. Right. So everything is ready. Now only thing is you need to do the detailing. So for detailing, first we'll go for a dimension. Before that, what I require one more point is curtailment point. So we have taken 400 as our curtailment point from the face of the support. So this is my face of support. Okay, from here I will take, let me turn on this ortho, I'll take a distance of 400 mm. Okay, so up to this point, okay, this is the curtailment point. Same is required on the other side of support. I just copy this with this end as my base point and paste it at this corner. Okay, so this is our curtailment point. Okay, now we'll go with the dimensioning. Okay, linear, right? So right, let me just format this dimension style. This will modify this one to text. Let it be standard text or Arial. Height will make it as 50 and see set current. Now okay, this is fine, this much height. So dimension, linear dimension. One is the clear span, right? So clear span is 5000 mm. Again, spacebar, repeat the dimension command, and support width we have it as 230 because it is coming 230. Okay, and on this side also again repeat the dimension command by pressing spacebar. Okay, 230. Yes, this is also 230. One more here. So, okay, hit the spacebar to repeat this dimension command. I have saved this. Now let me take it one more time. So this is indicating the point of curtailment, 400 mm from the support. Same on the other side. On the face of the support, we have one end of this line somewhere over here. It should be somewhere here, yes. So 400 mm. These are the curtailment points. Almost we are ready with the detailing of this beam. And what I require, I need to show this, represent that curtailment has been done over here. So it is done by something like this. Okay, same over here. Just take a line and take this point over here, and this is the curtailment. So you are now able to see the curtailment in the longitudinal section where actually the curtailment is done, right? So that reinforcement is drawn. Okay, we are finished with the drawing here. Only thing is cross section is remaining. Okay, so I'll take this cross section over here. I'll prepare that rectangle. So beam is rectangular in cross section. So 0, 0, first corner, I'll take that one. Then 230, comma 375. Okay, I'll be having that rectangle. Okay, at this origin. This I will move it near my beam. Okay, so here I'll place it over here. Okay, one more because two are required for us. So just prepare one more by copying this. Okay, that is sufficient. Now what I require here, I need to first show the stirrups. Okay, again what we'll do, we'll go for offset by pressing O command, O in your keyboard. You'll get the offset command. That is a shortcut for offset. You can even access here. This is a quick access offset. Again 25 mm is the clear cover. So with that I'll offset it. Here also I'll take it to draw the shear reinforcement, two leg vertical stirrups over here. Now these corners will not be square. They have to be uh, filleted. Okay, so they'll be rounded. So go for this fillet. Okay, fillet radius some 25. We'll give 25, and here, sorry, fillet radius are, okay, 25. So this is the fillet. Again, one more at this corner, fillet. Here also fillet. The radius has to be specified as 25 mm. Same for this one. Choose fillet, specify R 25. Okay. Once you choose the fillet command, first you can type R, hit enter. It will take the value of radius, give 25 as the fillet radius. Okay. And then we have this as our cross sections. So right now we only have the uh, shear reinforcement what we have drawn here. So one more thing what we need to do is just show these bars. Okay, these are bars tied at the corner over there. Okay, now I need to show the main reinforcement and the hanger bars in cross section. For that, I'll go for taking this donut. Okay, so donut outside diameter you can keep it as a 20, inside diameter make it 0. Okay, so this will be the where it went. Okay, so donut, what it is asking, inside diameter is 0. Okay, I gave it in reverse way, outside diameter is 20. So this is the first reinforcing 1, 2, 3, and 4 on the bottom side. On the top side, 1 on this end, other on the other end. Okay, 2 hanger bars. So here also 1. Okay, this is 1 more. On the bottom, since 2 have it curtailed, you are left with only 2 bars here. So these are at the corners here. Okay, so I'll just move them to the bottom. Be resting on that. Okay, so we are finished with all the sections, drawing all the sections here. And dimension in the cross section also will show the dimension for this. So this is the depth of the section. Turn on the source map. Depth of the section 375, and width of the section. Width of the section. Why it is not taking 230. So width of the section 230, and depth of the section 375. Okay, and now comes detailing. Okay, so I require the leader. So in dimension, I should be able to get this leader. Okay, leader, right. So bottom steel at the mid span. So this is my steel at the mid span. What is the text here? 20 mm. Okay, diameter it is 20 mm. So 20 mm, or you can just put it as Y20, and numbers are 4. Okay, 4 bars of 20 mm dia. Okay, if you want, you will also get this symbol. Double click on this. Instead of this, what you require, symbol, symbol, and diameter symbol. Okay, it can be put in this form also. Okay, so on the top also again choose this leader here. Okay, and take this one, just this line. Here what I have is 10 dia and they are 2 in number. Okay, so let me put that diameter symbol here. Just to double click on this text, you should be able to edit that. The symbol is diameter. Okay, so these are the main bars. Now here, this I'll take it after curtailment, right? So this is the point after the curtailment. Okay, right. Okay, this is point after the curtailment. Here, what is happening? Same 20 mm diameter bar are there, but 2 in numbers. Okay, and one more thing, what is required here? Copy this one. So these are what 2-legged 8 dia. Okay, 2-legged 8 dia at 175 center to center. These are the shear reinforcements. Okay. Slightly increase this. I'll increase that one. If required, you can change these things. Arrow size 25. Right. So this is same thing. What I require in the cross section as well. So this leader, I'll take it. So bottom reinforcement. Yes. Okay. Same in this section also. But the numbers are 2. Okay. And on the top side, dimension leader. So these 2 bars. What I have is these are 10 mm, 2 in number. So copy this one and same on this side. Okay, so they should be coming inside the stirrup. Fine. So this is the detailing part. Next, one more is for these stirrups. So this is for the stirrups. What I have for stirrups is here. Just control C and I'll paste it. Sir, sorry. So two-legged 8 dia, two-legged 8 mm dia at 175 center to center. Okay, so that will be the reinforcement details. Same on this cross section. Okay, you can also name this cross section here. This is section 1, okay, and the other one is, we'll call it as section 2, section 1, then here it is section 2. Okay, whereas this section 1 and 2 they are before and after the curtailment. So just show it over here. This is one section what I have. Okay, so this is one section. Just choose some other line for showing this section.